Hey everyone, welcome back. You know how much we love digging into the cool tools and techniques that help us make sense of data.
Absolutely. And today we're diving deep into the world of Python data visualization. Specifically, we're going to explore Matplotlib and Seaborn, two of the most popular and powerful libraries out there.
I'm excited to really get into this. We've got a great guide here, Python data visualization with Matplotlib and Seaborn. It seems like a really comprehensive resource for anyone who wants to learn, how to create compelling visuals from their data.
Definitely. And I think what's really great about this guide is that it not only focuses on the how-to, but also delves into the why, the importance of data visualization, which is sometimes overlooked.
Yeah, and sometimes I'm guilty of that too. I get so caught up in the coding part that I forget to step back and ask, wait, why am I even visualizing this data in the first place?
Right, exactly. It's like we need to remind ourselves that the goal is not to just create pretty pictures, but to gain insights, to tell a story, to communicate effectively with the data.
And I think the guide actually starts by addressing that very question. It asks, why visualize data? So let's start there. Why is visualization so crucial in data science? Why not just stick to numbers and spreadsheets?
Well, I mean, think about it. Have you ever tried to make sense of a massive spreadsheet with rows and columns of numbers? It's overwhelming, right?
Oh, yeah, absolutely. I mean, I get lost in those things all the time.
And our brains are just not wired to process raw data like that efficiently. But when we visualize the data, we transform it into something that's much more intuitive, something we can grasp quickly and easily. It's like taking a jumbled mess and suddenly seeing a clear pattern emerge.
It's like creating a map, right?
Mm.
Instead of just having a list of directions, you have a visual representation of where you need to go.
Exactly. And that map can reveal things that might be hidden in the raw data, like trends, outliers, relationships between variables, things you might completely miss otherwise.
Okay, that makes a lot of sense. So it's not just about making things look pretty. It's about actually uncovering insights that we might not see otherwise.
Precisely.
All right, so we know why visualization is important. Now let's talk about the tools we're going to be using. The guide focuses on two main libraries, Matplotlib and Seaborn. What can you tell us about these? Are they like rivals or do they work together?
They actually work together quite well. They complement each other. Think of it like this, Matplotlib is like the foundation. It's like the building blocks of data visualization in Python. It gives you a huge amount of control over every aspect of your plots. You can customize everything from the axes to the labels to the colors.
So Matplotlib is the workhorse, the one we use to get the basic structure of our visualizations down.
Yeah, you could say that. It's like the bare bones of your visual. But then comes Seaborn.
All right, so where does Seaborn fit in? What does it bring to the table?
Well, Seaborn builds on top of Matplotlib. It takes those building blocks and adds a layer of, well, for lack of a better word, beauty. It makes the visuals more aesthetically pleasing.
Hmm.
And maybe more importantly, it also makes it easier to create certain types of statistical visualizations.
Okay, so Matplotlib for control, Seaborn for style and stats. I'm starting to see the picture here. So before we dive into specific types of plots and all that, let's back up a bit. For someone who's totally new to these libraries, where do they even begin? How do we get these tools into our Python toolbox?
Luckily, installation is pretty straightforward. If you already have Python and pip installed, which most people do, it's literally just one line of code in your terminal. Just type pip install matplotlib seaborn and you're good to go.
Pip install Matplotlib Seaborn. Got it. Boom. Done. So once we've got these libraries installed, what then? The guide mentions some core functions like line plots, bar charts, histograms, scatter plots. Are those the essential building blocks we should focus on first?
They are, yeah. They're kind of like the bread and butter of data visualization. Once you understand those basic plot types, you can start to combine them, customize them, and build more complex visualizations.
All right, so master the basics, and then the possibilities are pretty much endless.
Exactly. And the cool thing is that both Matplotlib and Seaborn give you a ton of options for customization. You can change colors, add labels, adjust the axes, you name it.
Customization, I love that.
All right.
But isn't there a risk of going overboard with it? Like, how do we make sure our visuals are clear and informative without getting too cluttered or distracting?
That's a really good point. It's all about finding the right balance. Like any good design, data visualization should be purposeful. Every element should contribute to the story you're trying to tell. So yeah, you can go wild with customization, but always keep in mind what you're trying to communicate and who your audience is.
So it's kind of like visual storytelling, right? We're using these tools to guide the viewer's eye, to highlight the key insights, to make the data come alive.
I like that analogy, visual storytelling. It's a great way to think about it.
Okay, I want to circle back to Seaborn for a moment. The guide mentions its statistical power. What does that mean in practical terms? Can you give us some concrete examples of how Seaborn helps us uncover those deeper insights?
Sure. So, Seaborn has a lot of built-in functions for creating visualizations that are specifically designed to reveal statistical relationships in your data. For example, a pair plot, which creates a matrix of scatter plots showing the relationships between all pairs of variables in your data set. Or a violin plot, which shows the distribution of a variable across different categories.
Can you break those down for us a bit more? Say, I'm looking at a data set of, I don't know, housing prices. What would a pair plot or a violin plot actually show me?
Okay, so imagine you have data on house prices, and you also have information about the number of bedrooms, square footage, location, things like that. With a pair plot, Seaborn would automatically create scatter plots for every combination of those variables. So you'd see how price relates to the number of bedrooms, how price relates to square footage, how the number of bedrooms relates to square footage, and so on.
So it's showing us all the possible relationships between different variables in one go.
Exactly. And the cool thing is, Seaborn automatically calculates and displays correlation coefficients on the plots, so you can immediately see which variables are strongly correlated.
Oh, wow. That's so much more efficient than having to calculate those correlations manually. And what about the violin plot? How would that be useful in this scenario?
Well, let's say you want to see how house prices vary across different neighborhoods. A violin plot would show you the distribution of prices within each neighborhood. You'd see the median price, the range of prices, and the density of prices at different levels.
Ah, I see. So it's not just showing us averages. It's giving us a visual sense of the spread and shape of the data within each category.
Exactly. And you can even use Seaborn to create multiple violin plots side by side to compare distributions across different groups.
So we're talking about really digging into the data and uncovering those hidden patterns that might not be obvious just from looking at raw numbers.
Exactly. And Seaborn makes it so much easier to do that.
Now, I'm always fascinated by outliers. Can Seaborn help us identify those? I feel like outliers often hold important clues, right?
Oh, absolutely. They can be like red flags telling you to pay attention to something unusual. Seaborn's visualizations, like box plots or scatter plots, can visually highlight outliers, making them easier to spot. It's like they jump right out at you.
Right. And sometimes those outliers are errors, but sometimes they represent something genuinely unique or interesting that's worth investigating further.
Precisely. They can be like little mysteries waiting to be solved.
Okay, so we've talked about the why and the how of data visualization with Matplotlib and Seaborn,
Mm.
but ultimately it all comes down to real-world applications, right? What are some specific examples of how these tools are being used to make a difference in various fields?
Well, I mean, the applications are pretty much limitless. You see data visualization being used in healthcare to track disease outbreaks, in finance to analyze market trends, in environmental science to study climate change, really in any field where data is collected and analyzed.
So it's really about taking these tools and techniques and applying them to solve real-world problems, to make informed decisions, to tell compelling stories with data.
Exactly. And I think that's what makes data visualization so exciting. It's not just about crunching numbers, it's about using data to make a positive impact on the world.
Well, I think we've given our listeners a lot to chew on today. We've explored the why, the how, and the what of data visualization with Matplotlib and Seaborn. Hopefully, you now feel empowered to start creating your own visualizations and uncovering those hidden insights in your data.
And as you dive deeper into this world, remember that data visualization is an ongoing journey of exploration and discovery. Don't be afraid to experiment, to try new things, to let your creativity guide you.
And who knows, maybe you'll uncover the next big breakthrough or solve a problem that no one else has been able to crack.
The possibilities are endless.
So, until next time, happy visualizing, everyone.
Happy visualizing.